Right, so today in this video, we're going to be talking about quadratics, how to graph a quadratic in vertex form. What is vertex form? It is y equals a, x minus h, and then square it plus k. Right, remember that your a is going to tell you if your graph is going to compress or stretch horizontally. The h is going to be what we used to say. It's going to tell if your graph is going to shift left or right, and k usually tells us if your graph is going to shift up or down. And remember, there's something special about h and k. Remember that when we're dealing with any quadratics, what we want is to find the vertex. Our main goal is to find the vertex, right? But in order to find the vertex in the previous forms, we thought that we needed to find the line of symmetry, right? We had to find the line of symmetry to then plug it into their function or to our table to find their y-coordinate, to find the complete point. Vertex form I usually say is the easiest one because you already have the vertex, which is h, comma k, right? If you have the form, you're probably going to have your h and your k, put it in your function, you have your vertex ready. But what's special here is that there's the opposite. There's a negative right before the h. So if we have y equals x minus 2 squared plus 8, our vertex would be 2, comma 8. You can see it's not, you can see that it's not negative 2, even though in the function it says negative 2, because it's the opposite of 2, right, in the function. So if it's 2 in the function, it would equal negative 2. That's why it's the opposite of 2, that the vertex would be not 2 from the formula, right? So let's get into an actual practical example, and let's graph this graph, which is going to be the last one in our quadratics system. And then later on, we're going to be doing synusual equations and conical equations. To then later on transmit it into a computer website called Desmo. So one more thing I want to talk about before actually graphing this is that the a value, right, for every graph is going to tell you, right, if it's less than 1, if it's greater, well, what we can say is, if it's less than 1, we know that it's going to be stretched horizontally, right? And we know that if a is greater than 1, it's going to be stretched vertically, meaning it's going to be horizontally compressed. Remember, there's an opposition between vertically stretched and horizontally compressed, right? So just use the horizontal terms. Greater than 1, smaller than 1, horizontally stretched. Smaller than 1, horizontally compressed. But the schools or the IGCSE, whatever, does not require you to know this when graphing. Just wants you to tell you that if A is positive, your parabola is going to open up, and if A is negative, your parabola is going to open down. That's all that IGCSE requires. But there's an extra sort of information here. So let's say we have y equals x minus 2 squared plus 4. Right? Let's say we have this. What is our vertex? Our vertex equals 2, comma 4. So we go here 2, and we go up 4, which would be here. Right? And now the concept doesn't change. 2 points to the left, 2 points to the right. You can choose any. It's always easier to choose easier points in terms of absolute value. So let's choose 2 points to the left. So let's have f of, what do we have here? 1 equals 1 minus 2 squared plus 4. So remember, PEMDAS, we do 1 minus 2, negative 1 squared, 1. So we have 1 plus 4, which equals 5. So that would be 1, comma 5. 1, comma 5 would be about here. It would be about there, right? It's a little bit out there. So now, let's do the same, but let's plug in 0 to our equation, right? So we have f of 0 equals 0 minus 2 squared plus 4. So we know minus 2 squared is 4. 4 plus 4 equals 8. So if we just go 6 Right, this is positive. We just put the line there to indicate these are all positives. Right, I can put the line here, 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 and then I can have 7 here, and I'll have 8 there. Remember, down is negatives, up is positives, to the right positives, left is negatives. So we have 0, 8, and it will be about here. So remember, a parabola forms a shape, and it forms that curve that goes infinitely. Remember, we can just neglect these will have the same y points from 2. So this would be here, and this would be here, I would say. Right, and this is our parabola. Let's do the line indicating that our vertex will be through here. And thank you all for watching this video.